All right, grade 8s, we're moving on to 6.6 today. So far in the chapter, what we've been doing up to 6.5 is solving different types of equations. So whether it's one step or two step or various different kinds, you might do something like this and solve for what x is. In the last two sections, we're going to be looking at the relationship between a general equation. So rather than make this equal to 5, we might have something like this: y equals 2x plus 3, and determine how does that relate to a graph. And it's actually foundational for moving forward into the relations and functions units into grade 9 through 12 basically. So really, really important stuff to wrap your head around, that this is actually can be tied to this. Okay, so we're just going to start with looking at a graph. How many ways can you describe the relation shown in the graph? Well, one thing that we notice right away is that it's going down. We could even be specific. For every input of 1, the output goes down 1. And we could go even more specific and say it's a straight line. Okay, and in other words, it's a linear relation. If it's a straight line, it's always, we call that a linear relation. Okay, so we'll take a look at a few different linear relationships and we'll kind of apply them, figure out a table of values that might go with them, and then relate how that might look like on a graph. And in 6.7, we'll actually be graphing stuff. Okay, here's the situation. Misha sells hot dogs for $3 each and drinks for $2 each. A meal is a hot dog and a drink. The number of hot dogs is related to the total cost of the meal. And so they actually tell us. Now, normally you should be able to actually figure that out: $3 per hot dog plus 2 for the drink, right? But in this case, they actually give it to us. Okay, so completing the table of values is pretty straightforward. Okay, it's already got it started here for us, so we typically just keep going, usually the first 4 or 5. But you'll always find a pattern, right? And so the way we find the pattern is we actually take the input and we plug it in for h. So in this case, 1 times 3 is 3, plus 2 is 5. So if you got 1 hot dog, your meal would cost $5. If you got 2, plug it in here. 3 times 2 is 6, plus 2 is 8. If you got 3 hot dogs, it would cost you 9, plus 2 is 11. Now if you look at this, you can see that there's a pattern. It's going up by 3 every time. So if I had to keep this going, it wouldn't be hard to just add 3 every single time. Okay, so we're going to deal more with what's happening here in our table a little bit later on. Okay, so how can you use the table of values to find the cost of a meal when a person orders 9? Well, we could keep going all the way to 9, but if we have the equation, it's a lot easier just to plug in 9 hot dogs. 3 times 9, somebody's really hungry today, 27 plus 2, it's going to cost you $29 if you want to eat 9 hot dogs. Okay, and then same thing the other way. How many hot dogs when you're ordering 35? Again, you can keep jumping up by 3 until you get to 35, but if you have the equation, then you know that the cost is equal to 3 times the hot dogs plus 2, and so we could actually just plug in 35 here, and this should look familiar to us from earlier on in the chapter. This is a 2-step equation. Opposite operation, start with the stuff furthest away. 33 equals 3h, divide by 3 on both sides. So if you want to spend $35 on a meal, you're going to get 11 hot dogs out of it. Okay, so we're going to do stuff like this in this section, and then we're going to get into some more with the table of values as well. Okay. This is just some stuff in your book. This is basically how they get a table of values. It's just a different situation. In this case, it's how x is related to 20 minus 3x. So they basically use that to come up with the table, right? So for the x being 1, you would do 20 minus 3 times 1. Or in other words, 20 minus 3, which would give you 17. If you plugged in 2, you'd be doing 20 minus 6, which would give you 14. And so that's where they get that table. You can see that there's a relationship there. For every input that you plug in a number, you're going to get a different number out. Okay. When the change is constant, like we can see that it's always going down by 3 every time. When it's constant, and the change in the output and input is both constant, this is going up by 1, this is down by 3, then it's always going to create a relation that is linear. In other words, straight line. Right? So he's going to give us a straight line. Okay. All right, so, and then they actually plot this on the graph, so you can look in your book. This is the point 1 and 17, 2 and 14. You can see that it's always going down by 3 for every 1 that you go across. Now, whenever we're graphing something, you'll notice, and we'll get more into this in the next section, the first value goes in as your x. It's going to go along the bottom part, so 1 across, and then the second number is up or down. And we'll get more into that in 6.7 as well as the second example here today. Okay, what we call this, right, is actually an ordered pair. So we took all the values that were in our table, your first column and your second column, 1 and 17, become the ordered pair, 1 and 17. So we call this the x coordinate, and we call this the y coordinate. So the first number always goes with left or right, and the second coordinate always goes with up or down. Okay, we'll touch more on that as we get into the examples. So we call that an ordered pair. So we can use the table of values to get an ordered pair. And so in 6.7, we're going to actually take that one step further. We're going to take our ordered pairs and we're going to actually plot them on a graph. Okay, so we'll get right into this first example here. Previously in the chapter, we would have to figure this stuff out, but in this section, it's actually most of the time going to give us the equation. So Saskatoon Pizza charges $11 for a pizza plus $2 for each topping. An equation given is cost equals 11 plus 2n, where n is the number of toppings, c is the cost. So use the equation to come up with a table of values. So we'll start with that in A. So we have number of toppings and cost. Normally it's x and y, but it can be n and c, it makes no difference. So if you have no toppings, so you're just getting a plain pizza, $11. If you put 1 topping on, this becomes 2 plus 11 is 13. Shouldn't be too much of a stretch to figure out the pattern here. It's going up by 2, and that makes sense. It's actually in the question because there's $2 per topping, so for every pizza it's just going to go up by 2. There's my table of values. Okay, we're going to, next section, put these into coordinates. Okay, in B, use your equation to find how many, or the cost if you had 5 toppings. So the cost would equal 11 plus 5n. We actually did, well, it would be the next one here on the table as well. So then we plug in, or sorry, we plugged in 5 for n, so it would be 5 times 2. So, sorry, it should have been 2 times 5. Okay, so then you get 10 plus 11 equals c. So the cost is going to be $21 for a 5-topping pizza. Okay, check the answer, just make sure that your answer actually makes sense. You can kind of work backwards through it, but it's pretty straightforward to check that that's right here. Okay, $21. It would work in our table as well. Okay, so that's for A, this is for B. So then in C, that's the one where we're going to work backwards. How many toppings are you going to get for a $27 pizza? So you're going to plug in for cost 27. 11 plus 2n. And again, this is what we've seen in the first 5 sections. We've been solving 2-step equations. We've been working backwards, right? 16 equals 2n. And then the last step will be to divide by 2. Always working backwards, doing the opposite operations tells us you'd have 8 toppings. Is there even 8 different types of meat you can put on a pizza? I don't know why you put anything else. So there's our answer. So the 2 types of questions you're always going to see when you're given an equation is either you're going to be given the 1 value, so we had to plug in the 5, or we had to plug in the c and work backwards. You're going to see a trend when you work through some of these questions. You're always going to be asked those 2 things. Either the cost, find the toppings, find the cost. Okay. Example 2 gets us to look a little bit at the ordered pairs, or the coordinates I sometimes call them. The equation of the linear relation. So we're given y equals, now we got some negatives involved as well, which doesn't have to be scary, equals negative 5x minus 3. Some ordered pairs are given 0 and negative 3, 1 and negative 8, 2 and negative 13, 3 and blank, so we're going to have to find that, 4 and negative 23, and then blank and negative 28. So if an ordered pair works, then the first value is your x value, the second value is your y value. So just to start setting this up, we could set it up into a table of values. And that's actually going to help us quite a bit because we're going to actually start to see a pattern in this case. 0 and -3, 1 and -8, 2 and -13, 3 and something, 4 and -23, and then something and -28. So you might already start to be able to say, oh, okay, I can actually figure out what this one's going to be and what this one's going to be. But really what they're actually asking is, what is the y value that goes with 3 when x is 3? And here they're asking for what's the x value when y is -28. And so if we have the equation, we can actually plug it in. So I'll do it that way. Okay, so we'll take this first one and plug in 3 for x. We can actually take that equation, y equals -5 times 3 for x minus 3. -15 minus 3, -18. Maybe that was your guess, right? If you're looking at the pattern, you can probably see that does make sense. Okay, second question, we're taking the ordered pair, but this time we're given the y value of the ordered pair and we're missing the x value. So we would have to plug it in slightly different. We would have to plug in -28 as our y in the equation. -5x minus 3. And this is again, the rest of chapter 6 has led us towards this sort of thing where we can solve a two-step equation by doing the opposite. So just make sure you're carefully plugging these things in. If you're not sure what -28 plus 3 is, plug it in. Don't make a silly mistake and make it -31 or something. That's going to cause you some problems. Okay, the last step will be to divide by -5. A negative divided by a negative gives me a positive. And that's probably what you guys were guessing this was going to be anyway. And so a couple different ways to actually tackle that. Okay, so there's a bunch of questions you can practice from page 356.